Hi, welcome back to Aristo Think. Today I was solving this exercise because I always like to solve different exercises so maybe I can find a better solution because that was the initial solution that it was presented, the one I found. But I said, no way, it's too big. You see, I don't like to write too much in math because I believe math, the idea of math is for you to every year you write a better solution. You go faster to wherever you want to go, faster and safer, and being more objective year after year. I believe that is why I believe math is important. It forces us, or at least it gives us the opportunity to improve every year. So every year I can find a better solution, I can find a faster solution, a different one, and that makes me happy. So that's why I like to put math in my life. So, and I want to share this with you that are watching this video. Now, what are we doing here? Well, actually, we are making a Maclaurin series for this function. If you don't know what is Maclaurin series is this, because I want to explain to everybody, even the one that never heard this before. So imagine I have a function, a crazy function, a weird function, and of course we have no idea how to find its solution unless we have a calculator. But if you don't have a calculator in hand or a cell phone, whatever, well, then we're in trouble. But if we could approximate that function, that weird function, by a polynomial, it would be wonderful. And that is what is Maclaurin series. So the Maclaurin series is there. So you can express this crazy function by a simple one. And if you don't need a huge precision, well, you just need like 2-3 terms, not more than that. And exact terms, polynomial terms that you can get in any simple calculator. You don't need a scientific one to get it. So let's solve this one. Let's see what happens. Now, I start this already. Let me show you what's going on. So that was the first solution. I won't even read because it's terrible. I don't like even to write down. But then I'm going to show you on this video how we can find that nonsense becomes this lovely expression. You see? Now, this is f of x. So what is the Maclaurin? The Maclaurin series is a bunch of derivatives, and let's start to derive. So in my way of writing, I like to write Maclaurin series like this. So f of x is the original function. We're going to approximate by a g of x, which is going to be a polynomial. And it's going to be what? F prime of 0 plus the sum of fi prime to 0 times x to y divided by y factorial. Okay? That's what you're going to do. And what I make an abuse of notation here. I know I do, but it's practical. That's what I say. The idea of math is to make it simpler, right? So it's a kind of an abuse of notation. It is, but y prime. So it's the first derivative, the second derivative, third derivative, and so on. Now, I have to write this one here. This what? No, this is only f here. Sorry. Because I have to put this one outside because I don't have a zero derivative. So that is why. So we're going to have like this. Yes. Yeah, it is. So now the Maclaurin is going to be this. Okay. Now, how are we going to get this one? Let's go. So the first thing we're going to do is this. Let's try to find the derivatives. I'm going to show step by step how we're going to get there. So the first thing we're going to do is this. We're going to find the derivatives. So the derivatives are going to be here. The y primes, right? The y prime is going to be. So let's first derive this one. Derive once. Drop the power. Copy this one. Subtract the one here. So drop the power. Copy whatever is inside. Subtract 1. Wonderful. This is for derivative. Left derive again. Drop the power. Copy this one. And subtract 1. So drop the power. N minus 1. Copy whatever is inside the parentheses. And drop 1. Subtract 1 in here. Now I'm going to do again. Let me follow this one. I'm going to do it again. Last time. Because you see, we have to find a pattern. But to find a pattern, we gotta have, it's dangerous to find a pattern with 22. Very often we can say, okay, it's more than enough. I can have the pattern here. No, it's dangerous. I advise you to get some 3 or 4 terms so you can have a better sense of your pattern, if there is one, right? So drop the power and subtract 1. So n minus 1, drop the power. This is the dropped power. Now copy the parentheses, and this is going to be subtract 1, okay? Well, according to the chain rule, I would have to derive inside, but when I derive inside, is x is going to be 1, so it's going to add nothing. Now, let me just make sure that we know what we're doing. So our i's are going to be, this is for I1, this is for I equals to 2, this is for I equals to 3. So what's going on? So there is a pattern in here, isn't it? You see? Because, look, this is the same I, the same I, the same I, you see? And more. So this power is the same I, isn't it? And can you see that n minus 1, n minus 2, it stops a little bit before, but always one less. So this is a pattern. It's a clear pattern. Now, but I have to assess where this f prime. I have to assess f0. So let's assess this fy prime at 0. So what's going to be? So just put 0 in here on x. So it's going to be 1 to the power. It doesn't matter, right? Because if I put 0 here, everything in here is going to be just 1, always. This is going to be 1. So that part is always going to be 1. And also this one. This is also going to be 1. So this resumes to this. And you see, I'm trying to get this part in here, see? The f prime, you see, this part. Because this one is easy. Just raise this power, factorial, it's easy. But I'm getting this mess in here. So that part is this part in here, okay? Is this part in here. Now, this is going to be n, because it's going to be 1. Now, this is going to be n minus 1, the rest is 1, and then n minus 1, n minus 2. Okay, good. So you see, now let's try to assemble our g of x. So g of x, of course I'm going to have to raise the blackboard and create another one. I pause the video, but I pause the video. But we have another blackboard for certain. Now it's going to be, what is f of 0? F of 0, come on, let's start assembling our polynomial. F of 0 is going to be 1, right? Because put 0 here. 1 to whatever is going to be just 1. So 1 plus, now we're going to the sum. So what is going to be the sum? It's going to be the derivative at 0, which is going to be, the first one is going to be n, times x to the 1. I'm doing this part, right? I equals to 1. Divide by 1 factorial. Plus the next one. What's going to be the next one? F to the seconds to the 0, which is this. N minus 1. Only this. Times x to the seconds 2 factorial. And a little bit more. The last one. Again, is going to be what? The third derivative, which is going to be this one. But the third derivative at 0 is going to be this, right? So I'm just going to copy this. n minus 1, n minus 2. Okay. Times x. I is 3 right now, isn't it? We are here. I is 3, right? Times x cubic. Again, I'm going to get to this, okay? That's the idea. Because if it's a show only this, come on. You don't need a video for that. So 3 factorial. And it goes on. Goes on. If we want to. You see, just like I told you, we don't have any obligation to do like 10 terms. If maybe 2 terms are enough or 3, okay, be happy. You only get that and whatever the rest. But okay, so can you see what's going on here? So you see, I'm going to pause the video because I'm going to copy. I'm going to let only this in here. All right, because now we're going to continue from this, because this is what we have there, isn't it? If you notice, this is what we have there. You see, nx, n minus 1. Oops, this is x squared. Sorry. You see, x squared, 2 factorial, n minus 1, n minus 2. X. This is what is there, huh? This one anybody can do it. But I want to go further, okay? So I'm going to pause the video and continue when I clean the board. 1 second. Hold on. Pause. Okay, now let's continue. I erase everything. Now, this is exactly what we have down here. But I'm going to tell you something. I'm just going to put something more here. So to make more clear. What I would like you to see is these parts. I'm going to do in reds. Maybe you can see. I want you to focus on this part, on that part. What comes to your mind? What comes to your mind about the red part? Focus on that, you see? See, focus on this part. Let me see, maybe if I could do a little bit like this. Focus exactly in this part. Here, here, and here. What does it come to you? What brings to your mind when you see this? Well, you see, I at least I like to think this. Imagine they give you like this, x, 2. The combination of x, choose 2. Or maybe the Pascal coefficient, whatever, binomial coefficient. You choose how you want to call this one. The combination thing, right? So I always like to see like this. Can you see this 2? So it's x minus 1 over 2 factorial. That's how we do it. Or maybe if we had a 3, well, we're going to have 3 terms. 1, x minus 1, another one, thirds, because I have a 3, and then 3 factorial. Imagine I had a 4 factorial. So it would be 4 in here, and 4 factorial, and so on. So can you see what's there? You see? You see, no, when I was looking at this, I thought, no way. No way. I have 3 terms and 3 factorial. I have 2. No. This is too good to be true. And then I said, no way I'm going to write that thing in here. No way, I can make it better. So, what is this? This is nothing else than what? N choose 3. Try. Come on, let's do it. Let's do it together in here. So this is going to be what? I don't want to have space in here. I don't think so. Will? Maybe I will. I don't know. Let's try. Maybe I will. Let's see. Here, let's do it together. So this is going to be n factorial divided by n minus 3. I'm applying the combination, right? N minus 3 and then 3 factorial. But this is nothing else. Can you still see? Yes, you can. A little bit lower. Okay, this is still as n minus 1, n minus 2, n minus 3 factorial, stop there, n minus 3 factorial. I could continue forever, but I want to stop here because now look, cancel. That's why I stopped there. So 3 factorial. You see? Can you see? This is this, isn't it? So, and what would be this one? So this would be n choose 2. And this one. This would be what? N choose 1. And this one. Yes. Do you remember the Pascal triangle? It's the first one. But the Pascal triangle. Do you remember this one? 1, 2, 1, 1, 3, 3, 1, 1, 4, 4, 4, 1. See, no. You see, that guy in here, which is represented by what? N 0, right? So this is going to be n to 0. So you see, I can put everything with the Pascal coefficient or the binomial coefficients. So that's wonderful. That's wonderful. So now this is going to be what? This is going to be, so our g of x is going to be what? Is going to be, I can express everything, the sum, all right, to infinity of y going to, let's see how it's going to start. It's 0, right? 0. Then let's see if it works, okay? N, y. Then I have to multiply by this guy. This guy is out. X to y. Let's see if it works. So the first one, I0, okay? This one disappears. And this is just 1. Beautiful. Then 1 and 1. This is going to be only n. Perfect. And I is going to be 2. X squared. It's going to be n2. N2, I told you, n2 is n2. N choose 2 is n minus 1 over 2 factorial, because it's 2 factorial, 2 here, 3 factorial, 3 here, and that's it. So you see, this is the formula that I told you we would get. Interesting, isn't it? How can we find better solutions every year? I like this. Well, I hope you have enjoyed. I certainly have. I wanted to share this with you. And I think send a message. You see, and the idea in math is this. Math is there so it can enhance our mind year after year. So although we get older and older, but we should get smarter and smarter, and math help us doing this. Thank you very much for being on the channel. I hope you have enjoyed. Send your comments. Thank you. Have a wonderful day. Bye-bye. See you.